Welcome back to Outward Home Learning. This is computer science and we are looking at refining algorithms today. So refining algorithms is obviously a bit different to kind of reading and writing them. Mr. Holton's going to go through exactly what that means and what that means you'll need to do in your exam. So over to Mr. Holton.
One thing that you might be asked to do is to have a look at an algorithm which has already been written and look at and try and spot mistakes within it. And when you do this, you want to be looking for two different types of errors. The first one is syntax errors, so that is where you're looking for mistakes in the grammar of the code. And the other one is logic errors. Have a look at the video all about errors if you can't remember what these things are. And logic errors are where the code works, but it works in ways which is unexpected. So what we're going to do is show you an example algorithm. So here's one. And what's really important for us to do is really read what the algorithm is meant to do first off. If we don't do that, then we're not sure what the algorithm is meant to do and we can't fix the code. So let's have a quick look at this. An algorithm is written to calculate the cost of a camping trip. It is £10 per person. If there are more than 5 people, the overall cost is increased by 20%. Okay. Once we've read that, we know what the algorithm is meant to do. Then we can start to have a look at our code here and see if we can spot any sort of problems with it. Right, first thing I'm going to do is try and cover the syntax errors. So are there any syntax errors in here? See if you can spot those. I'll tell you here, at the bottom it says there are 4 errors overall. I'll give you a clue and say there's 1 syntax error in this. So see if you can spot it, and I'll give you a moment or two. And here you can pause the video if you need to. Here we go then. So the first error is here. I've got a pair of speech marks here, but I haven't got a spare pair of speech marks closing a particular string. Now that will cause a syntax error and stop your code from being compiled or interpreted. Okay, so that's the syntax errors done. Let's start working through the algorithm then and figure out what the logic errors are. So to do this, I need to test the algorithm with suitable test data. And if I'm reading through, I've got this £10 per person thing, and if there are more than 5 people, the overall cost is increased by 20. That suggests I'm going to need to do 2 tests, one where there's more than 5 people and one where there's less than 5 people. I'm going to do the less than 5 people first. So I'm going to do people equals 3. All right, I'm making up my own test data for that. Let's work through the algorithm then. See what happens if people equals 3. So we'll start on this line here. So I've set people equals 3. So I've got a box there, a variable called people, and it's got the value 3 in it. And then I've got here cost equals 10. Now it's instantly a little bit suspicious, but we won't worry about that now. So I'm on the second line, cost equals 10. So cost now has the value 10 in it. Next line, this one here, where I'm looking at the if statement. If people equals 5, then, well, people doesn't equal 5, and I'm not worried about this bit where it being more than 5 for now, although I can see something's a bit suspicious there. So I'm just going to skip past what's in this if statement and go to the end of the if statement, which will bring me to this line here, this last line, print cost. So I'm going to print out cost. So what's the result that I'm getting from my algorithm at the moment? It's 10. What should it be? Well, let's have a read again. An algorithm is written to calculate the cost of a camping trip. It is £10 per person, and I've said I've got 3 people. So the result is 10, but I should be getting 30. So I've instantly found a problem. Where's it going wrong? Well, the most likely candidate is this line here, cost equals 10. That should be multiplied by the number of people. So let's fix this bit here. So that should be cost times by people. All right, that's my first problem sorted. With that done, let's move on and let's try and do a different test. So if I've got people equals 3 and I work through that algorithm again now, I know I'm going to end up with 30. But let's try see what happens if I've got more than 5 now. Before I go any further this time, I'm going to actually figure out what the result is in advance. So if I have people, if I have 6 people, what should the cost of it be? Well, it should be 6 times by 10 because it's £10 per person, so it should be 60, but then it's going to get increased by 20%. So 10% of 60 is 6, so I know I'm adding 12 there to it, that would be 20%. So what I should end up with here is 72. That's the result I should get. Let's see what happens. So people equals 6, that's what I've decided, so I'm going to put people there. Cost equals 10 times by people. So that means I've got 6 times by 10. So I've got 60 there. It's all going okay so far. If people equals 5, then what does people equal 5? No, it equals 6. So something's clearly gone wrong here. This if statement here isn't checking to see if there are more than 5 people. It's checking to see if there are 5 people. And that is a very different thing. So that needs to be replaced with a different sign, and we want the greater than sign. So that's our third error that we've found there. Okay, so if people greater than 5, then cost equals cost times by 1.1. So that's going to increase it by 10%, and that is definitely not the right value, is it? That should be 20%. So here I'm going to end up with 66, aren't I? So that's my last mistake I need to change in the algorithm. That shouldn't be 1.1, it should be 1.2. Okay, so there's my 4 errors I've found, 1 syntax errors and 3 logic errors, all sort of packed together. And I've done that by just running through some test data. So that's for a fairly straightforward algorithm, but if you stick to the same principles of more complex algorithms and just track what's in the variables, run a test with known test data, check to see if the result is okay, then you can easily spot problems in any kind of algorithm.
So it's now time for your first task. For the first task, you're given an algorithm with a scenario, and there's some refinements that need to be made to it. So you're going to use that to make a new version of the algorithm. You can screenshot it on the activity document. You've got about 10 minutes to do that, and then we'll go through the answers. So that is your time up. We're now going to go to Mr. Barnes to review those answers for us.
Okay, so let's have a look at this refining algorithms activity. Now, you could have either copy and pasted the code into your IDE, or you could use the trinket. So I'm just going to use the trinket with the code already in. So the program should calculate the journey cost on a train for adults and children travelling together. So if I run it, let's see what happens. Let's move this slightly. So if I was passing through two stations, and there were two adults travelling and one child, it tells me the cost is £100 because it's £20 per station. So there's two stations, that's £40 per adult. There's two adults, so 40 times 2 is 80, and for a child it's half the price. So if it were £40 for an adult, it's therefore £20 for a child. Now, the task you were given was to refine this program so that it only allows children to travel if there are adults present. So I'm not going to get rid of any of the code, I'm just going to add some more code. Okay, so I'm going to say if children is greater than 0, so if there's children travelling and adults is equal to 0, which means there's children travelling but no adults, I'm going to do a simple print statement that says, what did it say? You cannot travel without an adult. Okay, and then I'm going to say else, and I'm going to indent the rest of it. So if there are children and there are adults, it will do the else part. If there are no children but there are adults, it will do the else part. So now let's run it. So I'm travelling through two stations, no adults travelling, and I've got two children travelling. It says you cannot travel without an adult. Let's run it again. Two stations, this time I've got two adults and no children, and it works out the cost. Run it again. Two stations, two adults, one child, and it calculates the cost. So it just stops it from children travelling on their own. Now there are other different ways you could do this, but that's just one example, and that's what you're trying to get to. So you could use that data to see if you get the same outcome as me. And if you do, then your solution's absolutely fine. There's always more than one way to do these things.
So it's now time for your exam style questions. We've got 2 questions for you today, and both of which you need to refine some algorithms based on a scenario. So you've got 10 minutes to do that, and then we'll check the answers with Mr. Barnes. Off you go. And that is time up, so now over to Mr. Barnes to review those answers. If you didn't get anything quite right, please make sure that you amend your answers as you go.
Right then, let's have a look at these exam questions as part of our deliberate practice, all based around refining algorithms. So we've got Julie's writing a computer game that simulates a 100-meter race. Each time the spacebar is pressed, the position of the player moves up by 1. When the position reaches 100, the player has won, and there is your algorithm. To make the game more interesting, Julie changes the rules. Each time a spacebar is pressed, the position of the player will now move up by a random number. State 2 changes that need to be made to include this new rule and justify each change. So I'm just going to shuffle this up. Okay, so first of all, I think it's worth noting about line number 6, where position equals position plus 1. Well, if she wants it to be a random number, it can't be position equals position plus 1. Okay, so the first change is going to be position equals position plus 1 needs to be changed. Okay, the justification, it will need to be a random number instead of plus 1. Okay. So the next change I think is worth noting is this here. Position until position equals 100, which is your loop. Now the reason that's no longer going to work, if it was a random number, let's imagine it was sat on 98 and then the random number generated is 5, it's going to jump to 103. Position will never end up being 100. Therefore the loop will continue forever. So I need to say the until condition needs to be position greater than 100. So obviously as soon as it passes 100, the game should stop after its most recent go. Alright, and why is this? Position may no longer be exactly 100 as it increases by a random number. Okay, so before we go on to the next question, let's go through this one and just check the mark scheme. So hopefully this will be nice and clear to see. Right, so my first change, I said position equals position plus 1 needs to be changed. So in the mark scheme, note it is e.g., so other suitable alternatives are allowed. So I've said here position equals position plus 1 needs to be changed. Well, that meets that, so that's good. And it says here, so the increment is a random number. It will need to be a random number instead of plus 1. Perfect. The next thing we got in the mark scheme is the random number should be relatively small, so the game remains interesting, because obviously if it stops when it gets to 100 and you say generate a random number between 1 and 1000, it may only take one go. I've not said that, but that's valid points in the mark scheme. We've got the end conditional loop should be changed until position is greater than 100. Yep. And I've said as the position may not reach exactly 100 as it increases by a random number. So that meets those 2 points there. And you could also have said that the program will need to actually generate the random number so that it does it randomly. But there's my answers for 4 marks. Right, the second question then we've got here. So a teacher writes a program to add up test scores for their class. All of the scores are stored in an array called scores. The class is only a small class with 6 students in. This is the code for their current program. Okay, so we've got total equals 0, and then what it essentially does is it adds to the total by working through each element of that scores array for all 6 students. Now looking at that, we've got a lot of repeated code. It screams out to me there should be a loop here. So I'm going to refine this program so it's more efficient using a loop, which is what we've been asked to do. So I'm going to put total equals 0 at the start because that still needs to happen. Now we know that this must repeat 6 times. Therefore I know that I can use a for loop, and I can put for x equals 0 to 5, which means the loop will repeat 6 times. Now x is a counter variable, so each time round the loop x will go up by 1, so it goes 0, 1, 2, 3, 4, 5. Therefore I can make use of x when I want to replace these numbers. So I can put total equals total plus scores, and in the brackets, instead of putting 0 or 1 or 2, I can put x, and it will take whatever x is at that point and put it in. And then I'm going to write next x, so my loop tells the end of my loop, and then the final line is going to be the same, where we've got print total. So let's have a look at the mark scheme for this one, and then what I'm going to do is I'm going to show you how it can be done in a different way as well. So we've got one mark here, initializes total as 0 and prints out total at the end. Well, I've done that. Uses iteration, e.g. for or while. Well, I've got a for loop. I'm going to go through how you can do it with a while loop in a second as well. That repeats 6 times. Well, 0 to 5 inclusive is 6 times. Correctly adds up the values using the loop index. So you see there I've got scores x rather than scores 0 or whatever, so that does that correctly. So that gets my 4 marks. I'm just going to quickly show you how you can do this exact same solution using a while loop. So you'd still set total to 0 at the start, and you'd manually this time have a counter. Counter equals 0. And we could say while counter is less than 6, total equals total plus scores. But this time, instead of x, we would write counter. Now, with a while loop, this variable will not increase on its own. So we then have to do a calculation that says that the counter at this point equals counter plus 1. And then end while. And then you can print your total. So it's a little bit more long-winded, because with a for loop x will automatically increment, whereas with a while loop you will have to have your counter variable and increase it yourself, but they're both perfectly valid answers. So there are your refining algorithm solutions.
And that is everything you need to know about refining algorithms for GCSE Computer Science. Well done for taking part. We will see you next time.